The new technology is not for everyone, and it is not for everywhere, and it is not for every time. So the goal of this day is to set in motion a path to think of where to put them first and start a multi-year purge of inefficient lights. So, since 2008, the efficiency of LEDs has significantly increased. Cost has significantly decreased. If it was a flat screen TV, I don't know how many of you bought a $4,000 flat screen TV a few years ago, but they're like $499 at Best Buy, right? So we watched the price come down dramatically and the efficiency and the quality go up. So we have a bias towards waiting. I've heard from major facility managers of some of the largest retail chains in the world that they're going to wait and see because they know that we are producing better technology and the price is coming down. And we can ask them a very simple question. What is the cost of waiting? Because there is a point with 24/7 big box and all kinds of places we retrofitted where it made sense to pick the locations in high cost electricity states and the long run time to start. Not to change all your lights today, just to start. The cost of waiting now is higher than the benefits of marginal improvements in efficiency and future cost reductions. And that is because the delta of efficiency over traditional lighting is now so large that the LED step improvements are less meaningful. So here's an example. 32 watts, initially we were able to bring down to 18. Then to 16, 15, then 12. I can tell you we will have something even better in the next year or two. No question, just like cars get more efficient. But if I can go from 12 to 10, and that's a 20% improvement, it is a tiny improvement over the delta of 32 to 12. So what happens is you have to make a decision about when it's good enough and when the price is low enough to say yes. And what we've seen is it typically needs to be inside of a 3-year payback. A 33% return on investment is typically a threshold where if you can get your money back, whether it's financed or not, for cash, inside of 3 years on something that will run for a decade, or in the case of an office, 2 decades, the comfort level is there to say yes. Four, as LED demand increases and rare earth materials are utilized, the cost reductions will also begin to bottom out. So there's this feeling that it's just this sort of pricing slide. Well, it's less than 2% of the installed lights today. So as the demand starts to increase, you're going to see the companies such as ours start to hold their price points because the phone's ringing at a whole nother level. And we do not have to lower and lower and lower and compete. And honestly, some of the Chinese companies are shutting down because they went so big so fast that they ran the RPMs too high on production. And there's now some gluts. LEDs particularly make sense today in high-cost kilowatt areas. I've talked about that, and long runtime areas. LEDs particularly make sense today in high rebate areas, and key point, the rebates may dry up, which is one more reason to act now. We've seen asterisks in the rebate programs that say we can terminate the program at the discretion of the utility company. They're not committed to decade-long giving away this money as a push to start the path. So someone that waits will not only potentially lose on the wasted energy they could have saved, but they will lose by possibly not getting the right price point and also the rebates. Target 3 or more of these 6 overlapping factors. So here's the idea. If you have high cost of electricity, you should consider the LEDs. If you have inefficient existing lighting, you should consider the LEDs. If you have long run time, you should consider the LEDs. If you have all 3 of those, you're crazy not to. because the math just works so well. If you find you don't have some of these, so Philadelphia is just under the kind of the 14 range, so we are at the US average closer into that 12, depending on how you're buying your electricity. You may not have the T12, you might just have the T8 fluorescent, so you've kind of got your B+ level lighting, and you might only be running your 8 or 10 hours a day. So you go into the lower side of the grid, which is, let's hunt for the rebates, let's look for the areas where you might be scheduled to relamp, or something you're planning on changing through an addition or some renovation, and let's see what you have as corporate goals or institutional goals for the energy conservation. So any number of 3 of these may work in the grid to justify a go, and I will repeat that it could be just a portion of a building rather than an all or nothing approach. Here's a map that shows where we hunt. Green is the heavier load in terms of cost per kilowatt. Yellow is the median in that 8 to 12 cents. And then the red is really the tough sell, right? So if they have in West Virginia a whole bunch of coal underground and they're burning it, and they don't have a big burden of transmission cost to move that electricity to your home or office, the cost is low for fuel, there will be incandescent, HID, and fluorescent bulbs in West Virginia probably longer than any other state in the Union. So be it. It's a $100 billion industry. There's plenty of room to make impact. Globally, we're seeing pockets where most of Europe is green, and in fact, Germany has over 30 cents if you convert the euro. They're way ahead of us. In terms of adoption, Europe and Asia are in the teens of LED adoption versus us at the 1.2 to 1.4 level, depending on which report you have. But we're less than 2%, and they're in the teens. And then you can find pockets of South America and Central America as well. US linear lighting, here's an order of magnitude. I referenced the 2.3 billion fluorescent tubes. That's a gigantic number. 50 years since the end of the Second World War when we started to really see the conversion. 48% are the T8s. That's the 32 watts. About 39% are still T12s. This blew me away. And this is DOE data. That's the 40, 45 watt level. It's like a 1980 station wagon. And you know, the fact that they've discontinued them, banned from the DOE to produce first the ballasts and then the tubes themselves. So the only reason you can still buy them through some of the big box stores or the eBays of the world is there was enough stock that was built in advance that we're sort of purging that old stuff. And then the 12% is the combination of the more advanced fluorescent and the others. A lot of numbers on this chart, but I wanted to pull it because we dug through the census and this US Energy Information Administration to get the number of buildings, the total floor space in millions, the floor space itself by foot, and then looked at an estimated average cost with the LED retrofits and the ROI, and we end up with these gigantic numbers, like $20 billion. It's amazing to think of what we can potentially save. Out of all the talk with climate change and sustainability, right in our own ceilings, we have an opportunity to do something today that has a massive impact positively for businesses and institutions, as well as the planet. Okay, the rolling retrofit we've talked about a little bit, and this idea of a leapfrog I'll introduce. When bulbs burn out, roll into the new LED technology and continue to purge. And don't replace the old ones with the next level. So if you had a T12, the T5 is a seductive form of technology because 45 to 26 or 27 sounds great until 12 is on the table. So I think there's got to be this dance of when and how it makes sense because you are acting to do something. The act of changing the lights has a sunk cost of the labor is to take that leapfrog approach. So we've sort of used these terms in the industry to encourage buyers not to think about waiting to change all their lights, but to roll as they burn out and then to simultaneously leapfrog to the best of the industry. New construction versus retrofits, go with the LEDs. If you're building something new, there's some architects in the room. I think over the last 3 or 4 years there was enough clutter. Architects were skeptical, and I'm one. I'm a lead AP, trained at Penn in 1993. I wrote my master's architecture thesis on energy intelligence. I called it then eco-humanism. Thought I was going to make all the money with building energy intelligence, and it took 20 years. So no surprise there. The world works at a slower pace than entrepreneurs might hope. For retrofits, I mentioned this before. Look for the ROI over the 33% because it's just a psychological hurdle to go beyond typically 3 years. College is 4 years. 3 is something you can kind of get your head around. The irony, of course, is with solar, unsupported, it's a 10% ROI. It takes a decade. So with 100 grand on the roof for solar, you'd be lucky to get $10,000 of electricity. You put 100 grand into the lights, and you're getting your 33,000 or more, every year out of it. Beam angle considerations. So now we're into the meat of which light versus why to buy the lights. So a wide beam angle will give you, for example, in a parking garage, a glow along the ceiling to reduce the visual impression of being squashed, the compression. The more normal beam angle would be like for an office where you want to just have the spread of light relatively evenly. And narrow would be for a retail or aisle lighting in a distribution center where you don't want to waste the light across the ceiling or necessarily across the floor, but you want to be able to read the barcodes on the warehouse stocking, and you want to be able to read the cans and the detailed print on the food labels in a grocery store. So this is where it gets complicated. And this is why I think the people that understand the fundamentals of math pause and say, well, I now need to see the lights in my own ceiling. And so don't be shy as buyers to also say, I want to see something. Thank you for the case studies. Thank you for the math. I want to see samples. And perhaps if you pay for them, don't be shy to ask for a return policy, which is I want to either front some portion of the cost or have the guarantee that if I don't like it, I'm not paying for it. But that's something that's your prerogative. Ask for photometrics. So in the case of the Anheuser-Busch distributor, which is called Gretz Beer, they wanted 30-foot candles on the floor from well over 20-foot ceiling heights. So we modeled a way to place fixtures and the output of the fixtures to meet their needs. This was not a commodity, this was a service. So that idea of being aligned with an end user's goals, business goals first, the needs for them to distribute their beer, which is forklift trucks, 10 18-wheelers that go in and out of there, the needs for humans to read labels, whatever it happened to be, on kegs and cases of beer. Working with the auditors, manufacturers, resellers, and representatives, plus the installers. Do it right once. There is nothing worse than buying new technology and having to replace it. If you have bought the wrong laptop, right, and the delay in transporting files back and forth, if you have bought the wrong phone system and you have to do it more than once, these are massive hurdles to overcome because it kills the entire ROI. The labor especially, and I start with the auditing and end with the install, because if you don't count them right in the beginning, you're going to probably have a redo of some aspect of that ceiling. Engage the experienced support companies or outsource people and check references and review the case studies. The service side of this is something I cannot stress enough. The LEDs are not yet at a commodity level where you can come in and just say at a big box store, I need hundreds of those, or pull them off the internet. It is still in its infancy where you need to have people engaged with you in many cases to support the sale. I referenced the rebates. Design Lights Consortium has what's called the qualified products list. Manufacturers such as ourselves apply. We submit our products based on third-party testing requirements. When we're on the list, you can have some confidence that at least the submission process was completed. So it is really a way that the utility companies teamed up to say, we want to have some standard that we can all follow to qualify the rebates. We want to have a list. And Energy Star does something similar. Energy Star is typically more for the socket bulbs than it is for the fixtures. Okay, I want to pause there for questions, and then we're going to dig into the second module. But we took care of the meat of the morning, so that was the heavy lifting. Yes, sir.
Great presentation. Thank you.
Thank you.
Two questions off the top. Does DLC testing or certification address only the initial efficiency, or does it look at the projected longevity?
Great call. So LM79 is efficiency. That is a test that is required. LM80 is the longevity. Both tests are required to submit for DLC. DLC is checking the box that those tests have been made. They are not doing their own independent testing to verify the findings. And I'll, just for the sake of the group, reinforce longevity. If we have 60,000 hours, and at 3,000 hours in an office, you know, call it 40 to 50 in a week, over 52 weeks, you get into that 3,000 range. That's 20 years. Well, you'd say, Charlie, thank you for telling me your product will last 20 years. How do you know? And what we do as an industry is we run 10,000 hours hot, and we look at the degradation level to see how many percentage points we've lost in output. And then we expand that over the life to get to what is called L70 death. 70% of launch light is the death of an LED. Still got 70%. So when you've lost 30, it is deemed dead. Unlike fluorescent, which is literally dark. So what's going to be really interesting in 20 years is who just leaves the lights going. Because with computers on our desks, we have individual light sources, and we've largely overlit the world for commercial applications, given work environments. So it'll be interesting to see if they really go for 30 years. Because remember, they're not dead. This is solid state lighting. What will happen is the drivers that are like the starters to the car may fail. And so without getting into the details of what we do, we have an external driver. I plugged in this tube and held it up without a fixture because we took the driver out as a thermal management opportunity to prevent the diodes from failing early and to have a modular component. But if that addresses your point, the testing comes in to DLC. They have lots of good requirements, but they don't do the actual corroborating the test. There's another question.
There's a huge expense to recycling the existing T5s, T12s, T8s. I noticed that I don't see any of that comparing the LED. Is there going to be recycling costs for LEDs?
So the high recycling cost is controlled recycling for the mercury. In the fluorescent, you're seeing something in the nature of 10 cents, you know, a linear foot. You're seeing something in the nature of 50 cents to control the recycling of a ballast. We pioneered about 3 years ago a cash for clunkers program where if you had the old T12s, we said, we'll pay for the recycling of the mercury and the, you know, the control of the disposal as an easy way to say yes to adopt the new technology. So perfect question, which is, there's friction in this decision, no question. That cost is paralleled with maintenance cost to change out the lights, not only the disposal, the air conditioning load, where the LEDs are running cooler and you can actually save on your air conditioning. So I think that when I talked about total cost of ownership, part of those calculations factor in all the hidden barriers to you know, a good decision, because it's interesting, unless you measure it, you truly can't manage it, because you might have the guy or the woman in maintenance on a ladder taking things out periodically. So it's not this sort of like big number that sits in front of you as a business decision maker that you can cut. It's trickled in sort of subsets. So I appreciate you bringing that up.
One of the issues we talk about a lot is whether to replace lamps or replace fixtures. What are the implications or the concerns we should have in making those decisions?
I brought a panel as a sample. This replaces a 2x4 in the comparable output with only 39 watts. It's got the ballast replacement, which is the driver built into the junction box, and it just is a lay-in to a grid. So if you have an old fixture that has aged, if you think of the parabolic, sometimes with the louvers you get bent ones, sometimes they are discolored. If you have an acrylic prismatic lens, maybe aesthetically it's got some chips in it, maybe it's got no shortage of stink bugs, which by the way the LEDs don't attract because there's no UV light. You may make an aesthetic decision that if I'm going to spend money, I want to go beyond changing something like the socket bulb or the linear module and change the fixture. We found, interestingly, in New Jersey, when we did work with the biggest Burger King franchise, the rebate was bigger on the panels. So if you have a $150 panel that will yield a $50 rebate to net to $100, and you can save $50 in a year, what used to be a 3-year payback just became 2 years. The linear modules, which were less expensive for a set of replacing 4 of them at $130, call it something in the $30 range each, we're only earning a $20 rebate. So the net math was panel was less expensive because of the rebate as a larger prescriptive solution than replacing the tubes. We showed them in 2 different Burger Kings, the tubes and the panels. Take the panels. We just did the math, and so we had to first show them the light quality. But this is that kind of solution selling that you can ask for, which is, hey vendor, I wish I knew what I needed, but I would like to see some examples of different solutions and show me the math for each at an ROI level and a total cost of ownership over time. And then I'm going to meet with my team and we're going to look at them. We're going to make a decision. We're going to bring out our foot candle meter and we're going to run the light output and we're going to see if it matches what you told me was going to come out of the ceiling. And we're going to make a decision that's an informed decision, not from looking at the price of a lighting technology. There was another one.
I have a project coming up, and I was looking at a Cree fixture in one of our studios. What would that fixture run cost-wise?
So in that 150 range, Cree might have one that's 120 but uses 44 watts. This one's 39. We are happy to show you side by side. With our solutions group, we can actually bring all the company's products to the ceiling. And again, we wear that kind of agnostic hat with the energy solutions group versus independence as the manufacturer, because we realize our products have a place and there's other great choices that are out there. So this is a big industry with thousands of lighting applications. No one company has all the solutions.
Yeah, one of the other questions, one of the aesthetic issues I have with it is when I try to use an LED, it's the Kelvin rating that becomes a problem. So has anything changed with the Kelvin rating on LEDs? Or?
So the most common Kelvin in commercial applications is 4100. That is sort of a neutral white. The bluer white bright light is in the 5000 and 5500 range for parking, hospitals, industrial. And then the residential and warmer for hospitality is often in the 2700 to 3500 range. Good news is, and I'll tell you this as a manufacturer, the layers of phosphor that we put on the diodes dictate the Kelvin. So when you are on the buy side, ask for samples to see. What I tell people is don't get just one sample, get a pair of them so you can look at them next to each other. So it might be the 3500, 4000, 5000 series in pairs, and run your foot candle meter, or your provider, directly underneath each fixture, but then between the two. So you can actually see the beam angle. Remember the diagram that had the wide versus the medium versus the narrow? So again, it's complicated, and I think I can't reinforce enough that it's complicated. And so I think we all maybe thought it was going to be a faster, easier matchmaking assignment to just switch it out. But we found that certain applications, like there's a trend towards going warmer in the office because you have that computer monitor. So instead of the old 50s and 60s fluorescent, you know, having a, for skin complexion, something in the 3500 range is more flattering. This is like about how the human body reacts to illumination as well as the wallet reacts to the savings.